yeah, we're excited to talk a little bit about the CWPPs that we've worked on in Colorado and how we started to include post-fire effects modeling in it. And probably by the end, I think we'll discuss some of the places where we'd like to go. I got a lot of great ideas from that first presentation, and Annie, what you said about connecting the kind of CWPP effort to the very complicated also planning for recovery effort. I think that there might be some nugget of a link in this work that we've started to do. So I want to just give a little context of where we're working and where we've done this so far. So this, in the northeast corner here, that pinkish area is the Denver metro area. So we are working just southwest of Denver. And we've completed 2 CWPPs that have included this post-fire modeling in it so far, which is Platte Canyon, the big one to the southwest, and then Evergreen. Genesee Fire Protection District is starting a CWPP with us. We just started this year. And so Meg's project managing that CWPP. And so each iteration we kind of learn a little bit more about this post-fire piece. But I just want to provide a little bit of context where we're working. Today I will be, all of the maps and kind of most of the discussion we'll have is around Evergreen, just because that is where we most recently finished our work. I also wanted to provide a little background on how we kind of came into doing this. We knew that so Forest Stewards Guild has been a part of the Burned Area Learning Network. There's been some engagement on this stuff before. We've also been doing CWPPs for a while. We wanted to find some new ways to kind of analyze data, have more tools for facilitating conversations with stakeholders, the Fire Protection District, community members. And so some of these are analyses that we've included that are brand new to those CWPPs that I showed on the previous screen. So looking at Embercast, looking at evacuation. The map over to the right is a model of evacuation congestion. Looking at roadway survivability. All of these are just, we're not going to go into any of those, but just to say that we're trying to use more tools, and so we looked into doing more post-fire effects modeling as a way to help understand the context that could inform where landscape scale fuels treatments should be, and kind of help prioritize and weigh the different factors that are going to be present in any fire protection district. I also want to bring up the treatment suitability. We'll address that a little bit later, but we also use that as a filter for knowing where treatment would be possible. So under 35% slope and within 1,000 meters of a roadway. So that'll be important later, but I just wanted to bring that up now, kind of in the context of how we're trying to prioritize and how this came up. So when working with the fire protection districts, the Platte Canyon and Evergreen in particular, these were some of the goals that the fire protection district wanted out of the post-fire erosion modeling process. So they wanted to know where worst erosion is going to be and what watersheds those are going to affect, streams, roads, things like that. And they really wanted to focus on utilizing this information as one facet of the suite of kind of tools to prioritize where on the landscape would be most important for conservation or for mitigation. And that's why I included that list on the previous slide, just to show that it's kind of in our most recent CWPP, it's one of the factors in determining where those landscape treatments will go. And I think there is room in the future for working more on that recovery side rather than the mitigation, pre-mitigation, where to, you know, determining where to place treatments. And I think one area that we would like to grow in is also using that data to plan for recovery. So I think the district wanted some idea of where to prioritize locations for post-fire action, to know, okay, if catastrophic wildfire does happen, these are some places where we should be sending resources, but no formal, there was less interest at the time in kind of a formal process of identifying what would those resources be, who would be doing those things, like the previous presenters mentioned. So I will kick it back to, Meg, to talk a little bit about the modeling that actually goes into figuring out where erosion is going to be worse. Meg is just an incredible modeler, and she's done all of those analyses on that last slide. That's all her work, and she's incredible at it. So I'll let her describe it, and then we'll get into talking a little bit how we incorporated it into the CWPP.
Thanks, Corrina. You can go to the next slide. Thank you. So we did a little bit of background research to figure out what models were available to predict erosion, and there's several that are out there. We ended up using a tool called the Watershed Erosion Prediction Project, and that is a model that was developed by the U.S. Forest Service, the U.S. Agricultural Research Service, and numerous universities. And there were a couple papers that we found that had looked at potential erosion after potential fire across large landscapes. So we followed the approach of those two papers with some modifications. So the model requires estimates of burn severity, and if you haven't had a fire, you don't have those estimates of burn severity, so you can use the predictions of flame length and convert that into burn severity, which is, there's some assumptions that go into that, but that's the approach that the model developers recommend. And then we needed information on soil texture, vegetation types, and percent cover. And the vegetation types, we related it to the land fire data that we used for our fire behavior modeling. And then we needed data on climate, so we used local RAWS stations, and then slope. So those are the main inputs. And next slide. So the Watershed Erosion Prediction Project is, there's several different interfaces, and no disrespect to the model developers, because it's a fantastic tool, but it is a little confusing because there's a lot of different interfaces to run this model. And I think part of that is because as technology has advanced, and they also have like a GeoWep, which runs on ArcGIS, but every time ArcGIS releases a new version, the previous model wouldn't work. So they're trying to do some online interfaces instead. But we ended up using the batch spreadsheet that they have. So we had to use GIS to determine like slope length and percent slope and vegetation type in the watersheds that we delineated. And then I had to modify a spreadsheet a little bit to make it interact with their online platform to make these predictions. The rapid response erosion database that you see in the lower right, that was developed by Michigan Tech with Mary Ellen Miller running that, and the Rocky Mountain Research Station, and then also NASA, is designed specifically to support with burned area emergency recovery rehab after a fire, so you can actually get the burn severity soil maps, and that data would be available on that erosion database, and then it's already ready to run in this Watershed Erosion Prediction Project. So I wanted to mention that because I know Annie had asked Corrina a little bit about how this erosion modeling interfaces with BEAR, and the Rocky Mountain Research Station and Michigan Tech have done a lot of work to make sure that their the model is able to support fair teams. Next slide. So some of the output that we got from this analysis is demonstrated here. So this is sediment delivery estimates in tons per acre per year. The model produces estimates based on 30 years of semi-random climate based on the averages over the year from the raws data that you give it. So this is the estimates from the 30-year average conditions. And we had to come up with the different bins to demonstrate this and to categorize erosion as low, moderate, high, and extreme. And in order to do that, we looked at some measured soil erosion from fires that occurred in the area where there was post-fire erosion. So we used that to kind of set the threshold, particularly between high and extreme. So we found a paper that said erosion from high severity burn areas of the Hayman fire had 11.5 tons per acre of sediment delivery. So coming up with those thresholds was something where we didn't want it to just be arbitrary based on like natural breaks in the data. So that would be different for different areas, kind of based not only on the distribution of the predictions, but also based on what's been observed in the past. So with our analysis, we found that about 15% of watersheds had the potential for extreme sediment delivery. So predictably, a lot of those are areas that have steeper slope and also areas where there's predicted high severity fire in terms of high flame length, because then that dramatically reduces the estimates of cover that would remain after fire. Next slide. So the model also produces estimates, the probability of sediment delivery, and some of the model developers say that they have more confidence in these probability predictions than the specific like sediment delivery, which is why we wanted to present both of them to the fire protection districts. So these graphs just show the number of watersheds that were predicted to a majority of the area to burn under high severity, low to moderate severity, or to be unburned. And then the probability of there being sediment delivery under a variety of different post-fire weather conditions. And it was just to demonstrate that where there is potential for fire, there is a high potential for sediment delivery. Next slide, please. And then to make this useful, we wanted to help the fire protection district see how the potential for high to extreme sediment delivery overlaid with values at risk. So we were able to identify rivers and streams that had potential for high to extreme sediment delivery, for ecological concerns, for habitat, and then also for the impact that sediment delivery in streams could have to reservoirs. So we were able to locate where there's reservoirs and where there's major roads that are in watersheds where there's predictions for high to extreme sediment delivery, because a lot of the wildfires in Colorado, when there's post-fire erosion, it takes out some of these mountainous roads and causes a lot of disruption for months and even years after the fire event. And I wanted to share that one of the data sources where I was able to find where there's like reservoirs and other values at risk was the Homeland Infrastructure Foundation level data, HIFLD. I'll put it in the chat. So that was a good resource that has like national wall-to-wall geospatial data that's open source, and it is useful for planning and risk analysis. Next slide. So also from that same data source, I was able to download where there's different communication sites, like radio sites, cell phone towers, where there's child care centers, healthcare facilities, and schools. And then we were able to figure out which of those areas are potentially at risk from post-fire sediment delivery. And we wanted to figure out which city and county parks could potentially experience some damage, and then which neighborhoods kind of self-identified neighborhoods or HOA units might need to think about what would you do if there was post-fire erosion. Like if you're in an area with high fire risk and high risk for extreme sediment delivery, do you need to have like a stock of sandbags prepared? So I think like Corrina will mention, we didn't quite get to that part, the discussion of like, what does this mean in terms of what is the fire protection district? What are neighborhoods? What are individual homeowners going to do to prepare and think about post-fire erosion? So that's why, yeah, I really enjoyed the first presentation because it made me think about how we could use this analysis and kind of take it to the next step. But this is the data that we're producing right now for our CWPPs. So I think that was all I was going to share.
Yeah. Yeah, I think exactly. I think that that's going to be really important for us to move into that next realm of kind of doing some of the, maybe including some planning for actual recovery. I also wanted to share one last map with you all of this treatment suitability. So if you may remember that some of the worst areas of predicted post-fire sediment delivery were in areas that are unsuitable. And so that was part of the conversation that we were able to have with the fire department on where treatments are going to be both possible for their crew and kind of limited funds to address, and where some of those areas where we do have high sediment delivery but are also accessible for treatment, those are going to become really high priorities. And you know, not a surprise, they often line up with other values and analyses that we did at being high risk. So if there's high erosion potential, there's also probably non-survivable roadway sections. And so where those are all treatable and kind of match up is how we ended up making some prioritization. Yeah, and this is probably a little, what I was just going to say here was that where we made recommendations were kind of in the protection and pre-treatment, but not actually in the kind of recovery of schools that are at risk, roadways at risk, just kind of identifying their existence and making a plan to go forward. We also included some recommendations here in the sources on the bottom, if you'd like to take a look on some of the pre-treatments that are effective for kind of identifying where these locations are, where some of these treatments are probably going to be really helpful and really necessary, along with other more traditional mitigation measures. And I just wanted to say too, someone brought up in the last presentation, the Postfire Playbook. This has kind of been our answer to not being able to dive in all the way to what recovery should look like, and kind of leaning on this as an appendix. So would love to hear from more people if they have any questions about that and kind of how we might move forward with better recovery pieces going into the CWPP, or other resources that we can direct the fire protection districts we work with to kind of take up that next, maybe it's a next effort, a secondary effort.